Okay, this is just a quick video for Brandon showing possible workflow of taking in a NURBS model and simplifying it and then getting a mesh out of it. So this is just a NURBS car hood that we imported with IGES. And it's got a couple of isocurves that are necessary for detail down here at the bottom, but are not necessary all the way up at the top. Um, so the first thing that we need to do is we need to convert this guy to T-splines. And once we do that, we have a new component here called deletable edges. Uh, and that just lets you create partial isoparms. What I do is I'll select a couple of these, go up to my modify selection. There's a bunch of tools for modifying deletable edges, but I'll just go ahead and extend those and then deselect the guys down here at the bottom that I actually need. And then I hit the delete key, and that will create some faces that are larger than other faces. But it'll still keep the shape as similar as possible. And this process is certainly not automatic, and the amount of change in shape that you're willing to accept is also something that you'll want to keep an eye on, but is pretty straightforward. You just select the edges that you want to delete. Um, let's see, and then just whack those guys. It will simplify portions of your model. So we've got these T-junctions here in the isocurves. We can also do this, the other direction, and just deselect the guys that are necessary to keep the shape on the sides, and that will give us some really big, T-spline faces. Or I can, do that manually if that's easier. Okay, so there is my surface. It's got, some fairly big faces here. And what I'll do next is I'll convert this guy to a mesh. So I'll just go in here to the convert to polymesh, open up the options, and I want use original as proxy. That'll just set up the history. See, I think I want to show yeah, I'm not sure if there's a way that I can get that meshing showing all the time. But under here, if I go into the select the object and open up the attributes, if I look at the T-spline output tessellation, uh, the default is to take each one of these faces and then split it into a certain number of polygons. So if I've got big faces, I get big polygons. If I've got small faces, I got small polygons. Oh, let me triangulate that too, just so you can see what the final triangles are going to be. There we go, triangulate. Okay, and this just shows you live, how many faces you've got for this car hood. If I switch that down to 2 divisions, it'll just be a 2x2 grid for each face on the T-spline, and you just have to decide whether that is acceptable for the shape versus the trade-off that you're looking to make. 1 division. The other thing that you could do is you could turn on a curvature check, and that just basically says I'm looking to get the the polys to within some some distance of the actual smooth surface, and so that'll tend to have higher poly counts in areas where there's more detail. So like if I put this up or put the tolerance pretty low, then I get a pretty dense mesh, but it's denser in the high curvature areas than it is in the low curvature areas. Let's see. Yeah, I guess that's about it. The other thing I was going to say is one thing that's very important to know if you're dealing with automotive data is right now T-splines do not handle trim data. So like this guy, he's just a single NURBS patch. It's running in a grid, but then he's got this hole cut out of him using a trimming curve. If I try and convert him to a T-spline, then it will just convert to a grid and lose a lot of that shape. Um, that could be a big problem depending on what your input data is. But yeah, if you want, let us know. Okay, I think that's it.